Okay, so we are on page 80. We have a hexagon here, and now when we read our question, they say, it is now a front view and a top view of a right regular hexagonal pyramid, cutting plane AA and BB, and starting point O. Okay, so our instructions are to draw to scale 1 to 1 the given front view, a sectional top view on cutting plane AA, and then a sectional left view on cutting plane BB, and you need to show all necessary construction, and then please show all hidden detail. I know they do not ask for hidden detail, but you will be assessed on hidden detail, so I'm asking you to please show hidden detail. Okay, so we say that one of our sides are 25, and we know that a hexagon is 6 equilateral triangles, so I'm going to set my compass on 25, draw a circle, okay, draw a circle, and then I'm going to start by getting my sides. And please don't draw your top view in solid because it will be sectioned. Okay, so I've done my top view in construction, please, and then an XY axis. And I will do my projection. I will also project point O, because that's actually now the peak or the bottom in this situation of my solid. So I will say that O is now there. I'm just going to do numbering. Okay, so I made point O, and I just numbered from anywhere, that does not matter. I started here and I numbered clockwise. 1 all the way to 6. Okay, so my total length of my pyramid is 74. So I'll set my compass on 74, and then from O, I will scribe my 74, and then I will do a solid line there. And this is solid. My front view will be a solid view, and then I will take each of these 4 points, so not the middle one here, because that is now actually point O. I will take them all the way to O. Okay, then I want to get my 2 cutting planes. So they say cutting plane AA is 37 millimeters from O, and it's just a straight line. And please remember, this must be a center line. It cannot be anything else but a center line. And on the sides, I just make 2 darker edges, the same as what they show on here. Okay, and then I'm going to do cutting plane BB. So they say that from O to the bottom here of B and on the side here it's 32. So I'm going to measure 32. And now it is not like this on an angle. Okay? They show the dimension up straight. So I cannot measure on an angle. Okay? I have to measure the dimension up straight. That is very important. Okay, so there and there. So for this one that I measured here, I'm just going to now project it in construction to the side to find the point there. And then I will do my cutting plane BB. Okay, so that's my cutting plane. Now they say they want a sectional top view on cutting plane AA. So now when I look at my front view, everywhere where line AA touches my solid, so there, and there, I'm going to project them down to my top view. Okay? So right there. There and there. And I need to see where it lands. So what I'm going to do is I'm going to transfer my numbering here to my front view. So 4 aligns there. 3 is actually now at the back. 5 is here in the front because I'm looking at it from this side here. 6 is in the front, 2 is at the back, 1 is on the side. So here, it falls on line 1 to O. So on line 1 to O right there, that's where it cuts. Then here on line 2 and 6 to O. So on, this is 2 to O there. This is 6 to O there. Same here, 3 to O, 5 to O, and then right here it will be 4 to O. Okay, so now what I'm going to do is I'm going to draw this in solid, so dark lines. I just want to check something might be a little bit skew, yeah? It is actually. It's this line. It's a little bit up. Okay, so there's my cut, and then I need to hatch it on a 45-degree angle, and it's a very small piece. And now the rule is we do not show hidden detail on a cut. Okay, so only on the sides of the cut. But now, when we look at this view that we are looking at, from the top, everything closest to me gets taken away. So the same rule applies for what you would have done in mechanical or so forth. What is closest to you on the section gets taken away. So we are looking at it from the top. Okay. So this is the only thing that stays is right here. Okay. Okay, yours might look a little bit different. I see I just made a mistake on where my 1 point is for my hexagon, but not too major. So yours will just look a little bit different here on the side. Okay, then they want a sectional left view, which we will then draw on the right hand side. So XY axis again. And then I'm going to do my projection for O across and then for the top across. So now I'm going to use my rule of similarity. So the one that I explained to you guys last week. I set it on my XY. I extend it to the number that I want, or the point. So this one now for me is number 1. Number 1 and number 4 align. So I only have to scribe it once. Okay? So this is number 1 and number 4. Then number 6 and number 5 aligns. So I just want to use the right one. So there. So this will be numbers 6 and 5. And then numbers 2 and 3 align. So right there, from the XY to numbers 2 and 3. And then set it there. 2 and 3. And then I must not forget about O. So O. And guys, this is why projection is important, because I need to set it on the XY, on the projection of that line, to the point that I want, and then I transfer it to the correlating projection. So this is O. Okay, then in construction, you connect your points. So there will actually only be 3 because it's the way that we are looking at the solid. Okay, so that is now my view. Now I want my cutting plane for cutting plane BB. So now B, here at the bottom, I'm going to project it across. There it touches, project it across. This point, I cannot project it across. It is parallel. Okay, so before I get there, I just want to show you how to get these ones. So now we need to see, okay, so this point cuts on line 1 to O. So on 1, there's numbers 1 to O. It cuts there. This point cuts on 2 to O as well as 6 to O. So there's 2 to O, there's 6 to O. Okay, so now somewhere here is going to be the other one. So how do I find that? I need to project it first to my top view. So I'm going to project it to my top view, and then it cuts on the edges. So right there and there. That is where it cuts. So then I'm going to use my rule of similarity again. Okay? So now what I do is I take the distance from 3 to the cut. So from 3 to the cut. Okay, hold on. Just wait. Give me 1 second. Can I just okay, so then it cuts over. You can look at the top view between line 2 and 3. So it's actually going to be a point view there, and between line 6 and 5 and a point view there. So you will connect it there to there to there, and then here and here. That is where my cut will take place, and then I take away whatever is closest to me so I can still see these lines here at the bottom, and then they will show me what is left of the solid, and then I will do my 45-degree hatching. And there, that is my then my sectional left view, and no hidden detail will be shown here because points 1 and 4 aligns with one another.